Okay, hi everyone. I hope this video finds you well. So we are talking about the Boolean logic. So in Boolean logic, everything is either true or false. So it's like I'm asking you, do you want to eat Thai food or Mexican food? And yes, this is not an answer, right? You have to give me a specific answer. Yes, I want Thai food, or yes, I want Mexican food. Now, the Boolean logic is if I ask you something, the answer to it would be either only yes or only no, without further explaining or further additions. So if I ask you, do you want to eat Thai food? And stopped, then you'd say yes or no, which is basically translate to true or false. Okay, let's start our lecture. So first thing you need to know is that you have to be able to answer those questions about variables before you continue in this lecture. Why? Because it's going to be critical to today's understanding to answer what are variables, what are the two basic operations they have, how do you declare variables, what is narrowing conversion, what is widening conversion. Now, you have to answer those, like what are variables? Named memory locations. The two basic operations would be override and retrieve, and so on. So what are the affordances for Boolean logic? Now we start our lecture. So the affordances are the ability to reduce information to single true or false. So if I ask you many questions and the overall would be making a decision based on those questions, either true or false. Like, should I go outside? Yes, based on what? I should ask myself a few questions before I say yes or no. Is it raining? Is it hot? Do I need to go outside? Something like that until I get to true or false. So those basically used in conditionals to help make choices about what code to run. And also used in loops to help make decisions or choices about if the loop should continue to run. So, the Boolean logic named after who? We had this before, and it's named after George Boole, who were a mathematician. So, Boolean logic is a form of algebra in which all values are reduced to either true or false. Boolean logic works nicely with computers because computers use binary numbers, 1 or 0. 1 or 0, right? True or false. So, Boolean logic is vital part of programming. Boolean logic only has two values, true or false. There are no maybes. It's either true or false. Boolean values are used to decide the flow of program, what to perform an action, whether to perform an action or not, whether to continue going on with the loop or not, and so on. So here's a conditional example with if statement, something you will learn in the future. If the temperature is greater than 98.6, then you have a temperature, you should go to the doctor. Else, which we use in plain English as otherwise, go to school, you're fine. Right? Go to school, you're fine. So we use it to make a decision. Either to go to the doctor because you have a temperature, or to go to school because you're fine. So that helped in decisions. This part, the temperature greater than 98.6, this is basically a question. Do you have a temperature greater than 98.6? If yes, you have a temperature, go to the doctor. If no, you're fine, go to school. In a loop, it's like you're in a game and how many guesses you have left and whether you won or not. So we'd say, if your remaining guesses greater than 0, you can continue being in the game. But you may combine that with the winning status. So if you won, even if you have 50 million guesses left, you won. You don't need them anymore. But if you didn't win, you have to check how many guesses you have left. If you have, then continue doing the game. If not, then the game would kick you out. So the Boolean expression produces a single Boolean value when evaluated, true or false. So may be composed of combination of Boolean constants, true or false, like when you use the word true or the word false in your code, or Boolean value, Boolean type variables, like when you define a variable of type Boolean, like bool is true equal true. Boolean value relational operators like greater than or equal, less than or equal, or checking the equality is 6 equal 6, which is 6 equal to 6, is true, is true, equal false, and the answer to that is false, because this is a question and you have to answer it with true or false. Or it could be a Boolean value functions that give back a Boolean, which is gonna be in CS131. Don't worry about it right now. So Boolean practice sentences. Let's practice them. So if the sentence is correct, you should say true. If the sentence is incorrect, you should say false. So whenever you have an example slide like this, you pause the video, think about it, and see my answer. But I will go on with the video. You can pause and play the video whenever you have an example. So the moon is made of green cheese. Your answer is? Okay, my answer is it's false. The moon is made of green cheese is not true, which means it's false. Ants are bigger than elephants. Your answer is? Now my answer is false. Because the bigger is the elephants. Okay, the moon orbits the earth. That needs a scientist, I know. Your answer is? My answer is the moon does orbit the earth, so this is quantified as true in the Boolean logic. Okay, common error. When you use the equal, it tests whether the two operands are equal. But when you use one, you assign a value to a variable, right? So since the equal operator is similar to the assignment operator, or confuses you, not very similar, you have to be aware when you use the equal versus equal. This one, test. Is my val equal to 5? Now you see that I start my sentence with is, which needs an answer true or false. This one I say my val equal 5, which means assign 5 to the variable my val. So be aware of that. So the Boolean expression has the form left value operator, then right value. Is 6 greater than 7? The answer to that is false. 6 is not greater than 7. Okay, so here is it. So is 6 greater than 7? The answer is false. So here is the relational operators: greater than, less than, greater than or equal, less than or equal, equal, and not equal, when you check for the not equality, not the equality, this is the opposite of this one. This one is asking, is x equal to y? Is x equal to y? When you use the equal. When you use not equal, which is the exclamation point followed by the equal sign, is x not equal to y? Now, example 1. You answer those, and I'm answering after you. So, is 4 equal to 4? Your answer is true. So, the answer is true. 4, in fact, is numerical equal to 4. Is 2 equal to 4? False. It's not. Is 4 not equal to 4? That is false, because it is equal to 4. Is 4 greater than 4? The answer is false, because it's not greater than. It's equal. Is 4 greater than 4? No, it's equal to 4. Is 6 greater than 4? Yes, definitely. True. Is 4 greater than or equal to 4? True. Why? Because we still have the equality. So, yes, 4 is equal to 4. And whenever you say yes or no in the exam or worksheets, yes or no is not acceptable. Why? Because we only accept true or false. True or false. So your answers must be true or false. When you even answer yes in the exam, in the coding, you should have it as true. As a human being, you say yes. I should see it as true. Okay, 2 greater than or equal 4? No. Which basically you should say false, not no. Okay, what is Boolean logic? How to use it? The Boolean logic is vital part of programming. Boolean logic only has 2 values, true or false. There's no maybe. It is either true or false. It allows the program to make decisions about whether to perform an action or not. So it is used to decide the flow of the program. Here is the relational operators we are using in this lecture. Now, go to Canvas, do the quizzes in the same module that contains this lecture. That's it. Have a great one, and see you in the next one.